In this example, for the first part, we are asked to find the H plus ion concentration, the H3O plus ion concentration, the OH minus or the hydroxide ion concentration, and the chloride ion concentration in a strong acid known as HCl, and we are given that the concentration of HCl is 0.015 molar. We're also given that the equilibrium constant for water is 1 times 10 to the power of negative 14. Now, since we're given a strong acid for the first part, we can say that HCl in water will dissociate into hydronium ion or H plus ion and chloride ions. Now, since this is a strong acid, we know that HCl is going to completely dissociate, which means that the concentration of HCl is going to be the same as the concentration of H3O plus or H plus, which is also going to be the same as the concentration of Cl minus, because that's a part of HCl as well, and they're all equal to 0.015 molar. Now, in one go, we found out the concentration of 3 of the things that we are asked to find from the question, and the only thing that we have left to find is the concentration of OH minus. Now, if we look back into the question, we see that we are given our Kw value, which is 1 times 10 to the power of negative 14. So we can use that to find our OH minus ion concentration. So we know that Kw is a product of H3O plus or H plus concentration times OH minus concentration. And we know that Kw is equal to 1 times 10 to the power of negative 14. We know that the concentration of H3O plus is 0.015 molar, so we can plug that in, 0.015 times the concentration of OH minus ions. Now, rearranging this, or dividing both sides of the equation by 0.015 molars, we get concentration of OH minus ions equal to 1 times 10 to the power of negative 14 divided by 0.015. This gives us an OH minus concentration of 6.7 times 10 to the power of negative 13 molar. Now, some may ask, how did we get the units? That's not a problem, because if we look at the Kw equation over here, we see that H3O plus has no squares or any other coefficients or any powers. So we know that we will have 1 molar over here and then another molar, which would multiply to give us molar squared. Now, we also know that we have 0.015 molar, so we have 1 molar over here. So molar squared divided by molar, at the end of the day, will just give us 1 molar, which is what we got here. Now that we know the final concentration of the OH minus ions, we are done with this part of the example. Now, looking at part 2, we have H plus, the same thing. We have to find H plus ion concentration or H3O plus ion concentration, OH minus concentration, and the concentration of calcium ions in 0.01 molars of CaOH2 solution. CaOH2, or calcium hydroxide, is a strong base. Now, for part 2, we have our CaOH2, or calcium hydroxide, dissociating into Ca2 plus and 2 hydroxide ions. Now, since we know that CaOH2 is a strong base, we know that the concentration of CaOH2 is going to be equal to the concentration of Ca2+, because it completely dissociates, which is going to be 0.015 molar. However, we also have the concentration of OH minus. If we look carefully, we'll see that in the reaction, for every mole of calcium ion, we're going to get double the OH minus ion. So for a concentration of 0.015 for calcium ions, we're going to get double that for our hydroxide ion. So concentration of hydroxide ion is going to be double that of the concentration of calcium ions, which is going to be equal to 0.030 molar. This time, we have the concentration of calcium ions, we have the concentration of our hydroxide ions, we also have the concentration of CaOH2. The only thing that we have left to find is the concentration of H3O+ or H+ ions. Now, just like before, we are going to use the equilibrium constant for water. So we know that Kw is equal to concentration of H3O+ times the concentration of OH minus, which is equal to 1 times 10 to the power of negative 14. We can add the units if we want, so let us add it here. So we will have molar squared. Now, or we know that the concentration of OH minus is 0.030, so we can plug that in. So we have H3O+ concentration times 0.030 molar equal to 1 times 10 to the power of negative 14 molar squared. Now dividing both sides of this equation by 0.030 molar, we get an H3O+ concentration equal to 1 times 10 to the power of negative 14 over 0.030 molar squared over molar. So we end up with an H3O+ concentration of 3.33 times 10 to the power of negative 13 molar, which is our answer. Let us now move on to the next example, which deals with weak acids and bases.